our calculators, we want to go to second distribution, which is the vars button, so second vars, and then you scroll down to Normalcdf. That's Normalcdf, and press enter. When you press enter, you may see a screen that looks like mine, or you might see a slightly different screen with the word Normalcdf and an open parenthesis. If you see that screen, hold tight and wait for us to finish this step. Alright, so in this screen, you would like to enter your lower bound, your upper bound, your mean, and your standard deviation. So what does this mean? Your lower bound, we want to know what percent of students scored between 82 on the low end and 90 on the high end, on the upper end. So our lower bound is 82, since that's the lowest we want our students to score. So our lower bound is 82, and our upper bound is 90, the highest that we want our students to score. And this little symbol here, or a little mu, that's where we put our average, and our average in this question is 80, and our standard deviation in this question, that little sigma here, standard deviation, we put 7 for standard deviation. Scroll down to paste and press enter. Now everyone else who has an older version of the TI-84, or perhaps you have the TI-83, you'd have to have done that manually. So in your calculator you would have typed or you would have seen Normalcdf, and you would have had to type in manually the mean, the lower bound first. The lower bound was 82. Then you would have to put a comma, and let me show you where the comma is. The comma is right here in close to the center of the calculator where my mouse is hovering. So you would have typed the lower bound, which is 82, the upper bound, comma, which is 90, the mean, which is 80, comma, and the standard deviation, which is 7. And as you can see here, we all end up with the same thing typed in our calculator, regardless if it's a new calculator or an old calculator. Once everything is entered, we can press enter. And that number that value is actually the percent, or the proportion of students that lie between 82 and 90, which if you look at our graph, that makes sense because that's 31%, approximately 31%, and 34% looks like this region. So this makes sense that this would be 31%. So our answer to our question, what percent of students scored between 82 and 90? Well, our calculator gave it to us as a decimal as 0.311 rounded. And if we convert that to a percent, we move our decimal place 2 places over, and we get 31.1%. So 31.1% of students scored between 82 and 90. All right, let's try another question. Okay, so in this question, we have the same mean. For convenience, same test, the same mean, which is 80, the same standard deviation. But now instead I want to know what percent of students scored above 85. Okay, so 85, again, it's not a nice neat number like 87 would be. See, 87 is exactly 1 standard deviation above the mean, but 85 is just a little bit below that. So if you were to guess how many people, or what percent of people scored above 85, you'd have to add this 2.14, the 0.1 over here, that's not written in, 13.59 over here. You'd add these values and then maybe add a tiny bit more. So the percent of people that scored above 85, we could guess, we have like 15, less than 20%. Okay, so of course we're not just going to guess, we're going to get this into our calculator and see exactly what percent of students scored above 85. Now, the thing is, if you scored above 85, you could score up to, many people would say 100% on if this were a regular test with a regular percent grade. But we're not sure how this test was graded. We're not sure if there was extra credit, bonus question. We're not sure if the maximum that could be scored is 100. So, in this case, if you want to figure out the percent of students that scored above 85, it could be 85 up to anything. It could be 85 up to a billion. So our lower bound we know is 85, but our upper bound is this unknown number. So in your calculator, you want to enter normal CDF, parenthesis, and again, if this is an old calculator, you'd put your lower bound, which is 85. But we don't know our upper bound, so we enter a really large number. And the largest number that we can enter in our calculator is written in this way. Now, 1e, 99, means 1 times 10 to the 99th power. It's a humongous number. We don't really have to put a number that big, but if we don't want to have to think about it, that's the biggest number that we can put as an upper bound, so we can use that. If you wanted to just put a really big number like 10 million or a billion, whatever you want to put that's really large in context, go ahead and put it. So normal CDF, lower bound, upper bound, mean, which is still 80, and standard deviation, which is still 7. So let's enter that into our calculator. Again, we go to second, vars, normal CDF, and again, I have the new version of the calculator. So mine looks like this. 85 is my lower bound. My upper bound is 1. To get to E, I go to second. The comma has E on top here. So E, 99. So that's my upper bound, a really large number. My mean is still 80. My standard deviation is still 7. And I can now press paste and enter once again. And I got, my estimation was a little bit too low, but I got that the proportion of students that scored above 85 was 0.238. 0.238. So if we wanted to give that as a percent, we would move the decimal place over 2 times and we'd get 23.8%. All right, so one final question. Same mean, same standard deviation. What percent of students scored below 70? So if we want the percent of students that score below 70, that's now our highest possible mark. So 70 is our upper bound in this case. So we're going to do normal CDF. And we don't have a lower bound in this case. We want below 70. Of course, you may say, well, you can't score below 0. And in most cases, that's true. But just in case, perhaps you want to get that small number in as your lower bound, just in case the context calls for a really tiny number, lower than 0. So for my lower bound, as my smallest possible number, I'm going to put negative 1e to the 99th, comma, my upper bound, because students have to score below 70 in this case, my upper bound is 70, my mean is 80, and my standard deviation is 7. So again, the negative 1e 99 is just the smallest possible number I can enter, and this is always what I will put for my lower bound. And this is always 1e 99 is what I'll always put for my upper bound. Okay. So now that we have that planned out, let's get everything into the calculator. Second, again, vars, so second distribution, normal CDF, enter. My lower bound in this case is negative 1e 99. And my upper bound is 70. And my standard deviation and mean are the same. So now we're ready to press paste. and enter. And we have here that that's equal to 0.0765, which if asked for this as a percentage, you'd move the decimal over twice and you would get 7.65%, which when you look at the diagram here, or 70 is approximately right here between 66 and 73, so it's approximately right here. And we have about 7% in that region shaded.